Welcome to the class. In last video we have seen conversion of rational numbers, that is p by q form to decimals, decimals to p by q form, and also we have seen three types of decimals. The first one is terminating decimal, second one non-terminating repeating or recurring decimal, third one non-terminating non-recurring decimal. We know that the first two types of decimals we get from rational numbers itself, like 2 by 3, 5 by 7, etc. Whereas the third type of decimals, non-terminating, non-recurring decimals, we discussed that these will come from the irrational numbers of the form root 2, root 3, etc. So, in today's class, I am going to find the decimal value of this type of numbers. Also, we are going to discuss how to represent these numbers on the number line. To find the value of root 2, root 3, etc., we are going to use the division method, which you have studied in class 8. To recall what is division method, I have taken a question here, finding the square root of 11,025 using division method. So, in division method, first step is under the root, whatever number is there, that we need to take in a box. So, I am taking 11,025 in a box. The second step is pair the numbers from right to left. Pair means two numbers. So, last two numbers are paired up. While pairing, keep the bar over the numbers. Next pair is 10. Last we have single digit. So, I am writing 0. Since if we write 0, it doesn't have the value, but it can be paired up. 0, 1. So, I have 3 pairs here. This is the second step. Third step, for the first pair, that is 0, 1. 0, 1 means 1. For 1, which is the nearest perfect square, we have to identify. What are the perfect squares? Those are 1, 1 ja 1, 2, 2 ja 4, 3, 3 ja 9, 4, 4 ja 16, and so on. These are called the perfect square. So, which is the nearest perfect square to 1? Nearest means here either that perfect square must be less than this or equal to this. So, here if you observe, 1 is the equal to 1. So, I am going to take this perfect square. So, how we got this one? 1, 1 ja 1. Let us subtract. So, 1 minus 1, 0. In division method, next step is bring the next pair of numbers down. So, what is the next pair? 10. Now, here I need to have a number. So, that to write that number, I am going to double this number. So, here what is the number? 1 is there. So, double it. Double means into 2. So, 1 into 2 is 2. Now, beside this, one more number should be written. That must be out of 0, 1, 2, 3, 4 up to 9. So, if I take 0 here, same 0 should be written here. If I take 1, I should write 1, 1 here. So, 21 1 ja 21. 22 2 ja 44. Like this, we have to multiply. But here 21 1 ja 21 is more than 10. So, I don't take 1 here, let me take 0. So, 20 into just written number 0, 20 into 0 is 0. So, 10 minus 0 is how much? 10. Continue the next step. Bring the next two digits down, that is next pair, 25. So, now I have 1025. Now, here to write the number, the first digit we get by doubling it. So, here now 10 is there. Doubling means 10 into 2, 20. Beside that, one more number should be written. The same number should be written here. That must be out of this. So, which number shall I take? 201 ja 201, 202 ja 404. Like this, if I take 5, I will get it as 5 5 ja 25, 2 carried 5 0 ja 0, 0 plus 2, 2, 5 2 ja 10. So, I got the remainder 1025 minus 1025, I got the remainder 0. So, square root of 11025 is how much? 105. In the same way, we can find the square root of 2 also. Let us see how to find root 2. That to here in the question, up to 3 decimals are asked. Let us see why they asked up to 3 decimals also. So, first step is whatever number is there under the root, taking that number in a box. That is the first step. Second step, keep the bars. But here there is a single digit, but they are asking up to 3 decimals. We don't get. So, what should be done? So, we are going to keep point here. Up to 3 decimals are asked. So, 3 decimals means 3 pairs of zeros you have to take. Pair means 2. So, 3 into 2, 6 zeros. 2, 3, 4, 5, 6. In case of decimals, let us see how to place the bars. For point on left side, to keep the bars, we move from right to left like the previous number 11,025. But right side of point we move from left to right. So if we move from right to left, last two digit bar, a single digit is there, so 0 1, 0 1 bar. The other side, so 3 4 5 6, but here single digit is there, so 0 will write 7 0. Like this we keep the bars. In the same way 2.00, here this side left to right, so 0 0 0 0 0 0, here single digit is there, so we can write 0 and then bar. So now let us see how to find the root 2 value using division method. So for that, first, what is the first group here? 0 2. What is the nearest to perfect square out of this? So perfect squares are this. 1 is the nearest one, so 1 1 ja 1. 2 minus 1 is 1. Since point is there, keep point here. Bring the next pair of zeros down. So next pair is 0 0. This I am bringing down. Now here what should be done? Doubling. So one point is there. While doubling, we don't consider the point. So close the point. 1 into 2 is 2. Now beside that, one more number should be written. That must be out of 0 1 2 3 up to 9. So how much shall I take? 21 1 ja 21, 22 2 ja 44, 23 3 ja 69, 24 4 ja 96. So 100 minus 96 is 4. Bring next pair of zeros. So 400. Now again the same step like this one. So double it, but before doubling, close the point. 1.4 is there. If I close the point, 14. So 14 into 2, 28. So beside this, one more number. Same number should be written here. That must be out of this. So if I take 1, 281 1 ja 281. If I take 282 into 2, that will be more than this. So 281 1 ja 281. Let me subtract. 10 minus 1 9, carried, 9 minus 8 1, 1 carried, so 3 is left out, 3 minus 2 1, 1 1 9. Bring the next pair down, next pair of zeros. Now once again same step like this, double it, close the point, double it. 141 is there, so 141 into 2, 282. Beside this, one more number. So which number shall I take out of this one? If I take 4, it will be nearest and less than this. So how much I will get? 2824 into 4. 4 4 ja 16, 4 2 ja 8 plus 1 9, 4 8 ja 32, 3 carried, 4 2 ja 8 plus 3 11. So how much I will get? What is the remainder? 10 minus 6 4, 9 minus 9 0. Here 1 carried already, so 9 minus 1, that is 8, 8 minus 2 6, 604. So I got the value root 2 as 1.414. Remember children, in the previous example, square root of 11,025 we have taken. 11,025 is a perfect square. If you multiply 105 with 105, you get it as 11,025. But here 2 is not a perfect square. If the number under the root is a perfect square, we get the remainder 0. That is why in previous case you got. Whereas here 2 is not a perfect square, we don't get the remainder 0. Which means the division will not stop. So division is not stopping. So it is non-terminating. And decimals also will not repeat. Even if you find up to 100 decimals, decimals won't repeat. So it is non-terminating, non-repeating decimal or non-terminating, non-recurring decimal. So irrational numbers of the form root 2, root 3, etc. will give us non-terminating, non-recurring decimals. But in the question, it is asked to find the root 2 value up to 3 decimals. But I have up to 3 decimals. Remember children, it is non-terminating, non-recurring. Non-terminating decimals will be coming continuously. So in such cases, we need to find the value up to 3 decimals. If they ask up to 3 decimals, find up to 4 decimals. So if I continue, here up to 3 came, one more step I require, but already 3 pair of zeros over. Since point is there, you can have any number of zeros. So I am going to bring 2 more zeros down. So here if I take, double the number, close the point, 1.414. If I double it, 2828, beside that one more number should be written. So what number I should take from 0 to 9, then if I multiply these two, I get less than this. If I take 2, here I will get less than this. So here root 2 is 1.414, 2 and so on. Here up to 3 decimals is asked. So here that is the approximate value 1.41. See the third decimal. Third decimal as it is we should not write. Up to 3 decimals is asked. So see the fourth decimal. In fourth place, if the digit is 5 or more than 5, we need to add 1 to the previous digit. That is 4 plus 1, 5. If it is if fourth digit is less than 5, we just neglect it. So if you see here, so 2 is less than 5, we'll just neglect it. So what we will write? 1.414. This is the root 2 value up to 3 decimals. In the similar way, we can find out root 3, root 5, root 6, etc. using division method. Remember children, while solving the problems with rational numbers, we have seen p by q form can be converted into decimals. Decimals also can be converted back. But this is not possible with this third type of decimals. Once after converting into non-terminating, non-recurring decimals, you cannot convert them back into root 2, root 3, etc. Now, let us move on to the next topic, that is representation of root 2 on the number line. Not only root 2, how to represent irrational numbers on the number line. To represent irrational numbers on the number line, we need to use two concepts. So, the first one is what is mean by right angle triangle. The second one is what is Pythagoras theorem. So what is mean by right angle triangle? The triangle in which at least one angle is 90 degree is called right angled triangle, or in simple way right triangle. So here I have taken a triangle 90 degree, this is 90 degree, this is called right angle triangle. Children, in right angle triangle we have three sides, AB, BC, AC. The side opposite to right angle is the longest one, and it is called hypotenuse. So what is here? Hypotenuse, AC. So AC is called hypotenuse. The other two sides called legs. In those two legs, this is base, we can call this one as base, whereas this one as the height. In every right angle triangle, if you see square of the hypotenuse, so hypotenuse is AC, square of the hypotenuse is equal to sum of the squares of two legs. So what are the two legs? AB, BC. So AB, BC are the two legs. Sum of squares of two legs, that will be equal to square of the hypotenuse. For example, if we have 6, 8, 10, here 10 is the hypotenuse, so 10 square. So that should be equal to sum of the squares of two legs. Two legs are 6, 6 and 8, squares and their sum. So 6 square is 6 into 6, 36, 8 square is 8 into 8, 64. Sum of this is 100. Same we should get from 10 square. 10 square is how much? 10 into 10, that is 100. Both are same. This is possible only for right angle triangle. Square of the hypotenuse is equal to sum of the squares of two legs. So here, to represent irrational numbers on the number line, we are going to use this concept of right angle triangle and Pythagoras theorem. This statement, square of the hypotenuse is equal to sum of the squares of two legs, is called Pythagoras theorem or Pythagoras property. While representing root 2 on the number line, first you identify in between which two integers root 2 lie. So here root 2, the next number if I say root 3, root 4, root 5, like this. The previous root 1. So here root 1 is 1, root 4 is 2. So root 2 lies between 1 and 2. So here the first integer, that is 1, is going to be base for the right angle triangle. So 1 unit is the base, that is one of the leg of the right angle triangle. A right angle triangle which we are going to use here, for that height is always fixed as 1 unit. So if I take 1 unit, how much will be the hypotenuse? Let me find out that. Here I am taking it as x. So we know that by Pythagoras theorem, square of the hypotenuse is nothing but sum of the squares of two legs. Two legs are 1, 1, squares of them and their sum. So here 1 plus 1, that is 2. X square is 2. So what is the x value? If I send square to other side, it will become square root 2. So what is this value? Root 2. So with 1 unit base and 1 unit height, I am going to get the hypotenuse as root 2. I am going to have this right angle triangle on the number line. So let us see how to do that. So here I have drawn a line. Now I have to convert it into number line. So here 1 unit I have written. if I take 1 centimeter as 1 unit, that will be very small and you will not be able to see it clearly. So I am going to change the 1 unit. You also can change. But 1 unit can be taken as 0.5 centimeter, 1 centimeter, or 2 centimeter, or 4 centimeter, or any length as per your convenience. So I am going to take 3 centimeter as 1 unit. So it is 0, 1.3, 6, 9, 12, 15. So this is 1 unit. Number line should be divided into equal portions. So 0, 1, 2, 3, 4, 5, etc. Here the numbers on the number line is having meaning. 1 means here from 0 to 1 this length is 1 unit. 2 means from 0 to this point the length is 2 units. 5 means 0 to 5 the length, this length is 5 units. So now I am going to have the base of the right angle triangle as 1 unit. That 1 unit must be from 0. Let me take this point 0 as O and at 1 as A. So this length is my base and height must be 1 unit. That at A I should have. At A I need to have 90 degree as well as 1 unit height. So 90 degree I require. So you can use your protractor and scale, or we have set squares in your geometry box. There will be 2 types of set squares. One is isosceles, the other one is scalar. So here if you see carefully, we have scale also, and in both of them 90 degree is there. In one set square I will have 45, 45, 90. In the other one 30, 60, 90 degree will be there. So any one set square we can use. I am going to use this one. The use of set square is 90 degree will be there, as well as the sides also will act as scales. So I am going to keep my set square at A, at 1, because 1 unit is the base at A. So this corner at here and this side along the number line. Yes, perfect. Along the other side I can have height. What is the height? 1 unit. Previously I have taken 3 centimeter as the 1 unit. The same I am going to take. So I have marked the point. Join A and that point. So I have marked it. Now let me take this point as B. Join O and B. 0 and this point. So base is 1 unit, height is 1 unit. How much I will get the hypotenuse? That is root 2. So I have the length of root 2 here. That should be brought into number line. So for that I am going to use the compass. By keeping compass and at O, take the length of OB, that is length of root 2. Now by keeping compass and at O, draw an arc such that it cuts the number line. Now this point indicates root 2. Children, hope you understood. So what we have done here, first we identified root 2 lies between which 2 integers, 1 and 2. So 1 is our base, height is always fixed, that is 1 unit. But if we check by Pythagoras theorem, with base 1 and height 1 unit, we get hypotenuse as root 2. That we brought it here. So from 0 to 1 unit base, and we have taken this point as O and this as A. We have drawn height of 1 unit, and if we join O and B, we got the hypotenuse with the length root 2. That we have taken using compass and drawn an arc from O. Where this arc cuts, that point is nothing but root 2, means this length is the length of root 2. This is how we represent irrational numbers on the number line. Children, instead of root 2, if they ask represent root 3 on the number line, then what should be done? So here also root 3, just before that root 2, root 1, root 4, root 5. This is 2, this is 1. Root 3 lies between 1 and 2. So once again 1 will be my base for the right angle triangle. So with 1 unit base, height is always fixed, 1 unit height. I need to have a right angle triangle. But if I take 1 unit base and 1 unit height, what is the hypotenuse? Root 2. But I don't get the root 3. So what should be done? We need to have one more right angle triangle. Okay, with root 2 as the base, height is always fixed. This is a 1 unit. Then how much I will get? If I take root 2 and root 2 as the base and 1 unit as the height, how much I will get the hypotenuse? Let us see. So here legs are root 2 and 1. Their squares and their sum, that is equal to square of the hypotenuse. So here square and square root will be cancelled. So root 2 whole square is 2 plus 1 square is 1, 3. This is x square. So what about x? That is root 3. If I send root to other side, root 3. So what is the value of hypotenuse in the second right triangle? Root 3. So I am going to have both of them here. Let us observe how we can do that. So take this as O, A. Keep your corner of the set square at A and the one side along the number line. Mark 1 unit height. So I have taken 3 cm as the 1 unit. So like the previous one, you have to continue. So if this is 1 unit, this is 1 unit, I get root 2 as the hypotenuse. But I want root 3. Root 2 is base for me. I require height at this point. Let me take this point as B. So at B I require height. So what I am going to do is mark the 90 degree and 1 unit height. So 1 unit is for me 3 centimeter. So this is 1 unit now. Height is always fixed. If I join these 2 points, this is root 2 is the base, height is 1 unit, hypotenuse I will get as the root 3. Take your compass. From O to, let me take this point as C. So from O to C, you take the length. By keeping the compass end at same O, draw an arc. So this is my root 3. So root 3 lies between 1 and 2. Root 2 also lies between 1 and 2. I got, in previous case also I got between 1 and 2. Now also I am getting in between 1 and 2. Like this, we can represent root 3. So to locate root 3, we require the previous number, that is root 2 on the number line. If you don't know that, the previous number, we should know where is that on the number line. So 1 is there. Now we mark root 2. Then after that, root 3. So remember, if you want to mark root n, you should know where is root n minus 1 on the number line. For example, if you want to mark root 6 on the number line, you should know root 5 first. Where is on the number line? That means you have to mark root 5, then only you can mark root 6. Take the question. Represent root 7 on the number line. The first step is identify root 7 lies between which number, which 2 integers. Root 7, root 8, root 9, this is 3. This side root 6, root 5, root 4. This is 2. So root 7 lies between 2 and 3. So 2 is my base for the right angle triangle, 1 is the height. If I take 2 units as the base and 1 unit as the height, how much I will get? Let me take this as x. So x square is sum of the squares of 2 legs. 2 legs are 2 and 1. So 2 square plus 1 square and their sum. 2 square is 4, 4 plus 1, 5. So x square is 5, x is root 5. So I am going to get the hypotenuse as root 5. So I am not getting the root 7. The root 7 just before that, root 6. I should know where is root 6. So how I will get one more right angle triangle with this hypotenuse as the base and 1 unit height, I will get root 6. With root 6 as the base and hypotenuse as 1 unit, I will get root 7. So here 3 right angle triangles I need to construct on the number line. So let us take a number line, divided this into equal portions with using scale 0, 1, 2, 3, 4, 5, etc. So here root 7 lies between 2 and 3. So what is the first integer? That is 2. 2 is my base. So 2 is my base means from where to where I have to take 0 to 2. Let me take this point as O and this point as A. So at 2 I need to have right angle as well as height 1 unit. So let me take this 1 unit height. Join B to O. Now 2 units, this is 1 unit, with that how much I will get? Root 5 is the hypotenuse. Next again I need to have one more right angle triangle. Now taking root 5 as the base, mark 90 degree. Yes, this is perfect. Along the root 5, mark 90 degree and 1 unit height. 1 unit height. So that 1 unit is for me 3 centimeter. So this is this. Mark the point. This is 1 unit from here to here. Now join these 2 points. With root 5 and 1 unit height, With root 5 as the base and 1 unit height, I get root 6. Next, again mark the 90 degree, and by taking the root 6 as the base, mark 90 degree. So root 6, this is 90 degree, perfect. So like this I have to draw. Now 1 unit height, this is perpendicular. Now only 1 unit I require. So this is scale for me, 1 unit I am marking. So up to here. So B, C, let me take this point as D, join D and O. So with root 6 and 1 unit as the height, how much I will get? Root 7. Now take your compass. Now take the length from O to D, perfect. Draw an arc by keeping compass and at the same O. Draw an arc such that it cuts the number line. You can see this. So this is my hypotenuse. Hypotenuse is converted into number line. So what is the length of the hypotenuse? Root 7. So this point indicates root 7. So from 0 to this point the length is root 7 units. So like this we can represent root 7 on the number line. So to represent root 7, we should know where is root 6, we should know where is root 5. Those irrational numbers we don't know. So we need to have those right angle triangles for these two also. First we need to locate them, then the root 7. If you want to get root 2, we have done is this 0 to 1 we have taken as the base, 1 unit height. This is root 2, hypotenuse is root 2. By taking root 2 as the base, height as 1 unit, we got one more right angle triangle with hypotenuse root 3. Now by taking root 3 as the base, 1 unit height, we got one more number, that is root 4, which is 2. If we continue like that, we get different right angle triangles with different hypotenuse, which are the irrational numbers. So if we see here, we started from here. If we join these points, it comes like this. It is called a spiral. This spiral we got from the irrationals, that is of the form square root. So this is called square root spiral. Children, it will be very interesting. You can do yourself, and so by constructing square root spiral, at least take up to 25, you will get the spiral like this. Now see this question, represent root 3.5 on the number line. Children, the previous method which we discussed using right angle triangles is not suitable for the all irrational numbers. For example, if we have 1 by 5, this is also an irrational number. 1 by 5 is not a perfect square. 2 by 7, this is also not a perfect square. So how to represent irrational numbers like this, or root 3.5 or root 5.1? For this, that method is not suitable. Here all the fractions also can be converted into decimals up to 1 digit, remember. Then we can represent on the number line using the method which we are going to discuss now. Children, to represent irrational numbers of this form, you need to know how to draw a perpendicular bisector. So for that I am going to take one line segment. Let me name this one as AB. So to draw the perpendicular bisector of AB, this is the length of AB. Half means maybe this much. More than half you have to take on the compass. Now from A you have to draw arcs, as well as from B. For which line segment you are drawing the perpendiculars from the end points of them. So on either side of the line segment, 2 arcs. From A I have drawn, from B also you have to draw such that they cut the previous arc. So now if we join the intersection points of the arcs, that is called the perpendicular as well as bisected. So bisected means this point is the midpoint of AB. So this concept we are going to use to represent root 3.5 on the number line. So now to represent root 3.5 on the number line, take a line, not a number line. Now taking scale, mark 3.5 plus 1, whatever number is given, plus 1, 4.5. So I am going to mark 3 points A, B, C at 0, 3.5 and plus 1, that is 4.5. So at 0 1 point, at 3.5 1 point, plus 1. So these are the 3 points. A, here 1 point, this is second point B, This is third point C. So now draw the perpendicular bisector for AC, that is 4.5 centimeter for AC. So more than half from A to C. So more than half, maybe this much. You can take any length, more than half. You can take this much or this much or this much or less than that. But it should be more than half. Draw arcs from A and you are drawing a perpendicular bisector for AC. So arcs must be drawn from A and C. So from A on either side and also from C you have to draw arcs on either side and cut the previous arcs. Now if we join the intersection points of arcs, that is called the perpendicular bisectors. So I am going to mark this intersection point, which is the midpoint of AC, as O. So now taking O as the center and the radius as OC or OA, both are same. Draw a semicircle. This is the third step. Now at B you need to draw a perpendicular such that it cuts the semicircle using set square or protractor. I am using set square. So at B 90 degrees. So this corner at B and this edge along the line. So 90 degree I am marking and intersecting the semicircle. Let me take this point as D. Now the length of BD is nothing but root 3.5. So we have the length of root 3.5. Let us draw a number line separately. So the number line is divided into equal portions 0, 1, 2, 3. I want the length of root 3.5 on the number line. So take the length from, using compass, take the length from B to D, which is root 3.5. Now keeping compass end at 0, draw an arc. So this is here. It is cutting the number line at this point. So this is my root 3.5. It lies between 1 and 2. So this is my root 3.5. This method you can use for root 2, root 3, root 5 and so on also. This is useful for all the irrational numbers. Let us review it once. You have taken a line, not number line, a line 3.5 plus 1. So we have marked 3 points A, B, C. You have marked A, B, C such that AB is 3.5, AC is 4.5. Second one, we have drawn the perpendicular bisector and from A and C. Mark the midpoint as O. Now taking O as the center, OC or OA as the radius, I have drawn a semicircle. Fifth step is we have drawn a perpendicular at B such that it cuts the semicircle. Mark that point as D. And fifth point is the length of BD is equal to root 3.5. This is useful for all the irrational number to represent on the number. Children, in between any two rationals there will be infinite rationals. What about irrationals? In between any two rationals or irrationals, how many irrationals will be there? To understand that, let us see this one. Root 1, root 2, root 3, root 4. Root 4 is 2, root 1 is 1. So in between that, how many we are seeing here? 2. Only 2 are there? No, nothing like that. Here if I take root 2.1, that also lies between 1 and 2. If I take 2.2, that also lies between 1 and 2. Root 2.3, root 2.4, root 2.5, those also will be lies between 1 and 2. Not only those, 2.001, 2.00002. Like this, I can take any number of irrationals in between 1 and 2. So what we can say is, in between any two rationals or irrationals, like rational numbers, there are infinite irrationals. Let us take a question here. Classify the following as rational or irrational. The first one is root 27. It is under the root 27 is there. That is not a perfect square. So we get irrational. Second one, square root of 441. Here 441 is the perfect square. That 21 into 21 we will get 441. So it is the square of 21. So is equal to 21, it is rational. Next, 0.50, 50, 50 and so on. Here and so on is there, so it is non-terminating. And if we see here, same group of digits are repeating. This is non-terminating repeating decimal. Second type of decimal we call as rational. Fourth one 0.50, 500, 5000, 50000 and so on. And so on is there. So it is also non-terminating, but looks that digits are repeating. If you see, observe carefully, 50 extra, 10 extra, 5000 compared to here, one more 0 extra, like this every time one 0 is coming, etc. So the digits are not repeating. This is non-terminating, non-recurring decimal. That is third type of decimal. Third type of decimals we get from irrational number. So it is irrational. Next one 0.324, 567845. Such a big decimal, but and so on is not there. So it is terminating decimal. Terminating decimals are called rationals. Next 30.2323, 4, 2, 2, 3 and so on. And so on is there. It is non-terminating. Digits are not repeating. So it is third type of decimal. That is non-terminating, non-recurring decimal. So it is irrational. See next question. Find two irrationals between 2 and 3. So it is easy to write non-terminating, non-recurring decimals which are called as irrationals. So in between 2 and 3 means I have 2.5. Even 2.7 also, 2.1 to 2.9 I have in between 2 and 3. So 2.5 is a terminating, but I want non-terminating, non-repeating. So let me take 50, 500, 5000, every time 10, etc. like this. So it is non-terminating, non-repeating decimal which is called irrational. I want one more. So 71, 74, 744, 7444 and so on. So these are the two required irrationals in between 2 and 3. Next question. Find two irrationals between 0.6 and 0.66. To understand easily, 0.6 and 0.66. Here 60 I am writing, which is same as 0.6. So in between this, if I take 0.65, that is in between these two. So 0.65 I can take one more. Let us take 0.63 also, but I want non-terminating, non-repeating. So 65, 6555, 6555, 65555 and so on. Now let us move on to the next one. 0.63 also lies between this. 63, let me write it differently compared to the first one. 663, 6663. So every time 6 is increasing. 66663 and so on. These are the two irrationals in between 0.6 and 0.66. Take 8th question. Find an irrational between 1/5 and 2/7. An irrational means 1. 7. To write non-terminating, non-recurring decimals in between those, we need to find out 1/5 value, 2/7 value. 1/5 value is 0.2 and approximate value of 2/7 is 0.285. So here 0.2 and 0.285. In between that we need to choose an decimal. So 0. If I take 4, 0.24 lies between these two. Here 28 is there. Here if I take one more, it is 0. 0.24 lies between these two. So 0.24, 244, 2444. Every time one I am increasing 1 4. So it is non-terminating, non-repeating decimal. It is called irrational. Find an irrational between √2 and √3. So here also one irrational we need to find out. √2 and √3 we require in decimal. So we need to use long division method. This is 1 mark question only. Using long division method will be lengthy. So you need to remember some of the values, at least √2, √3, √5. √2 is 1.414 approximately, √3 is 1.732, √5 is 2.236. So we need the values of √2 and √3. So √2 is 1.414, √3 is 1.732. So in between this 1.4 and 1.7, I can take 1.5 and so 1.5. Let me take 1.58, 588, 5888, 58888 and so on. This is my answer. In previous video, when required number of rationals are asked, for example, if two rationals are asked, in between any two rationals, we have taken 2 plus 1, that is, we have multiplied numerator and denominator of the given number with 3/3. But finding irrationals in between two given numbers is little bit different. That method we can't use here. So writing non-terminating, non-repeating decimals is the easiest one. There are other methods also, but this is the easiest one. Hope you understood. Take your homework now. There are 10 questions. First one, hypotenuse is the dash side in a right triangle, shortest or longest. Second one, in a right triangle, the square of hypotenuse is equal to the sum of squares of two legs. This is dash theorem, Pythagoras or Aryabhatta. Third one, root 11 lies between dash and dash. Which integers you have to identify? Answers are given there. Fourth one, explain with an example how an irrational numbers differ from rational numbers. Irrational numbers ki rational numbers ki difference ఏంటనేది ఒక example తో explain చేయాలి. Fifth one, find two irrationals between 2 and 3. Sixth, find two irrationals between 0.7 and 0.77. Seventh one, find an irrational between 5/7 and 7/9. How many more there may be? Eighth, locate root 10 on the number line. Ninth one, find the value of root 5 up to 3 decimal places. Tenth one, find the value of root 7 up to 6 decimal places. This is your homework. Now let us see the answers for worksheet 3, which is given in last video. Smallest even prime number is 2. The prime factors of 30 are 2 options are given. The first options are nothing but the factors. The second one is prime factors, prime numbers, which are the factors. The third one, 4/5 gives terminating decimal. Fourth one, non-terminating, non-recurring decimals are called irrational numbers. 0.62, 62, 62 and so on. This is non-terminating recurring decimal, so it is rational numbers. Second type of decimals are called rational numbers. Sixth one, write prime numbers between 1 and 2, 3, 5, 7, 11, 13, 17, 19, 23 and 29. Seventh one, I have given 4 rational numbers and asked to represent them as decimals. So here are the answers. Go through them. Next, 8th question, decimals are given. Convert them into P/Q form. So for this one also answers are given on the paper. You can check your answers with this. 9th question, without actually dividing, find which of the following are terminating decimals. 3/25, 11/18, so 13/20, 41/42. By looking at the denominators, if they are having prime factors 2 or 5 only or both, then we say such fractions will give terminating, or else they give the second type, that is repeating decimal. So answers are given. Check your answers. Thank you all.